Alright, welcome back. So this video is going to be one of two where I briefly jump into structures. There's a lot to learn with structures, but I just really wanted to split this video in two because the first time I recorded is extremely long. So I'm going to tackle the basic syntax of a structure, and then jump into a little bit more in depth of working with structures. But basically, structures and classes are really similar, so I really wanted to mention both of them in this video, that they're both very flexible constructs that will be the building blocks of your code. So they're very important, and I'm working out a strategy in order to introduce some of the more complex uses for them and working with them, but I just really wanted to start off with something really simple so we could just jump in, okay? But I'm also going to introduce object-oriented programming briefly, probably after my structure videos and just before the class videos, dealing with classes. Because I think understanding object programming is actually going to help you out when you're trying to learn classes. So I found out. Alright, so structures. What are structures? Well, structure is basically a container or a collection of different elements that, with functions, give you many possibilities in order to work with them and to use them in your code. And what are they? Well, first of all, they are a value type. Now, if you remember from my prior videos on closures, closures are considered reference types. So with reference types, you can have two variables looking at the same closure, but they know absolutely nothing about each other. And when you copy one closure to another, that new closure has a copy of that prior closure only copies its functionality, right? It just references the same friggin' closure. Well, structures aren't like that. Structures are value types. So if you copy a structure into another structure, they are going to copy everything, okay? So let's stop talking. Well, I should stop talking and really show you what a closure is. So what is a closure syntax? So it's pretty simple. First thing, or not closure, sorry, a structure syntax. Well, first thing you need to do is just type in struct. That is the first thing you do to signify that you're going to create a structure. So struct. The next thing you need to do is give it a name. So you're going to type in some structure here. Again, this is just simple syntax. Now, if you notice here, I capitalize the first letter. Now, this is really important with structures and classes that you use a capital letter, preferably a noun, because it represents an object of some sort or a thing, right? This is not a verb like, when we created our functions, we used like active words or our verbs in order, because they do something, right? So in this case, we're not going to be doing something, we're going to be defining something. Alright, so I'm going to say some structure, or curly brackets. And then inside of these curly brackets, we're going to put our structure definition. So structure definition goes here. So there you go. That's a very simple syntax. All right. Now the thing is when I started learning about structures, it was nice seeing structures and reading about it in a book. But the thing is, it was like, okay, how does this work? How does it apply? Well, thing is I found out the best route to go was to look at something I already know. We've worked with tuples before, and you remember what tuples are? They are basically a variable or a constant that contains a compound value that the programmer deemed relevant, right? So in my prior video, I did something like var full name, and inside of this variable we had a compound value. One contained the first name, the other one contained the last name, because logically that makes sense, right? So we're going to do equal sign. Let's go ahead and do that. So we do first name, let's just say Bob, and then last name, say Schmidt. Okay, so there we go. There's our tuple. And it looks really similar to what we've used before. And if you remember how we access them, access the different parts of the compound value, well, we use dot notation, right? So we do full name, and we say we want the first name. Well, we just type in first name, Bob, right? Or we could have done indexing and just did .0, right? And sure enough, Bob. So again, we know how to access and create a tuple. Well then, if you know how to do that and you understand that, then you understand structures. And you'll see what I mean. So let's bring up structure. So let's do exactly the same thing we did up here, but as a structure. Now it's going to be a little different, but really, really similar. Okay, so again, we do struct, and I'm just going to do, instead of doing full name, we're going to create a person, right? So I'm going to say person, curly brackets, and now let's define what this person is. Well, this person has a name, right? So we're going to do, actually I'm going to do a constant because I want to introduce something. All right, so we do first name. Now remember, when we define variables that don't have a value, we need to define its type. Well, that's the thing with structs, you have to define its type. As you see here, we get this wonderful error. Type annotation missing in pattern. This is exactly what I'm saying. It just says, hey, I need a type. Okay, so just give me one. So there we go. It should be happy. It's happy. All right, and then we do let last name. Let's do string. Okay. There you go. That is a structure. That looks really simple or similar to our tuple, right? Okay. Now you're saying, okay, well, it doesn't have the variable or the value Bob or the value Schmidt, right? Well, the thing is yeah, it doesn't. But that's because we want to reuse this structure in many different ways, because there's multiple people in the world, right? Not just one person. So how do we do that? Well, we create instances, or we initialize the structure in order to use it. Okay? So how do I initialize a structure? What is this instances thing? Well, again, that's kind of where object-oriented programming comes in. Basically, there are many instances of the same type. Just as we have an instance of person or a human being, right? But there are many different types of human beings. So that's why we introduce instances. They are similar to the original type, but they're different because of what their values are. Hopefully I explained it. I'll explain a little bit more detail in my object-oriented programming video, which will come next week. But I kind of wanted to introduce that concept. So, because you can have multiple people, but they need to have the same function, or they need to look the same as the other, right? Okay. So I'm going to create a person here. And instead of creating a person, yeah, let's do a person. Let's have a good example of a variable. Okay, let's say we have some players coming in, and they're people. They're not computers. Let's say there's two people about to play tennis or something, or soccer, all right, or football in Europe, right? So, so we're gonna have player one come in. We need to add a person to our team. All right, so how do we create an instance of a person? Well, what we do is we call our structure person. Okay, and we get wonderful errors as it needs arguments. So how do we add those arguments? Well, we do parentheses, and wow, there are there is our values that are the variables, constants that we set up here in our structure. Let first name and last name. So let's give some values here. We'll say Ann Jones. Okay, so there we go. So there is an instance of person. Okay? And if you noticed, when I first put in, I'm going to just create one more person, or one more player that happens to be a person. Okay, so when I first typed in the structure name and I did the parentheses, this layout where you have first name, the whole day, or the bookmark for the value, last name, and the bookmark for the value, this behavior is called a member-wise initializer. So member-wise initializer. This is where the structure takes each field of the structure as a parameter. So it really kind of looks like a function. You know, when we create a function that has parameters, and when we call that function, it pops up, you know, all the parameters it needs for you to fill out in order to use that function. Well, it's kind of the same thing. And this format only applies to structures. It doesn't apply to classes, only structures. Now there's a way to do this customized. You can customize this, but this is the default functionality of a structure. I just kind of want to introduce that because it kind of does look like a function, right? Well, that's just the way structures roll, okay? So, so let's go ahead and create one more player. Let's call him Boris. What's a good last name for Boris? Let's just do Godard. I don't know if that's the last name, but I'm gonna have fun. All right, so we have two instances of person. They're totally different people, they have totally different names, but they have the same structure. So here we go. Okay. So how do we access this then? Well, if you remember above from our tuple example, what do you think would access it? Dot notation. So let's do some dot notation. So let's say, hey, what's player one's first name? Well, it is Ann. See, you have Ann right here. It's Ann. All right. And what about the last name of player two? Well, it's Godard. Okay. So again, it's really structures blend a lot of things that we've already ran into, that we've already used. Just it's the concepts that we have to get down. Okay, so you're saying, well, Shawnee, I mean, okay, we have tuples. Why don't I just use a tuple instead of a structure? Well, the thing that makes structures so amazing in comparison to a tuple is that structures you can add functionality to. You can add functions to it to make it much more powerful than a tuple. Because the only thing a tuple can do is hold values. That's it. Can't hold anything else. So let's see what I'm talking about. Because, you know, you gotta see what Shawnee's talking about. You can't take her by her word, right? And I don't expect you to. All right, so yeah. Oh, I said I'd do dot notation. I'm going to copy that and move this up here so you know that refers to that. Okay, so adding a method. So what's this functionality that I'm talking about? Well, I'm actually going to copy this, but I'm going to rework it. I'm going to create a more extensive player function. Alright, so I'm going to rename that structure player, but I'm going to kind of keep some of the stuff that I developed here for person. Only because I want to really extend this and add methods or functionality to it to kind of show you the difference between tuples and structures. Okay? Alright, so function. So first thing I want to introduce is that how do I create functionality? Well, the thing is we need to actually add a function to the structure. That's how we create functionality. So I'm going to actually create a function in here that will output the full name instead of us having to like piecewise mill, the full name by like, combining it outside of the structure. We can actually call a function to say, hey, output the full name. So we're going to do full name and then our parentheses. Now this should look familiar if you viewed any of my closure videos, that I use this type of format for functions inside of closures. Same deal applies with structures. Thing is full name doesn't accept any parameters, and that is because it has access to everything inside of the structure because it's enclosed. So it's within its scope, okay, inside of its scope. And scope meaning that it can see everything that it is enclosed in. Okay, it can't see anything outside of structure. It can only see what's inside of structure of player. Structure of player, okay? So what I want this function to do is I actually want it to return something for me because I want to see what the full name. So I'm going to return a string to our curly brackets, and we're going to do return, and because it's going to be a string, we need to do string interpolation. So we're going to say first name space last name and then our double quotes. Okay, so there we go. That is our method. Now again, I want to make this clear that a function inside of a structure equals a method. Okay, so when I say method from now on, think function inside of something. Alright, now if this function was outside of the structure, then it would be called what? A function. But because of where it's located, this function is actually considered a method. But as you see, I mean, how we created it is exactly how we would create a function. Whether it was outside or inside, we use the same thing. Another thing I want to point out is our constants up here. Now, we can have constants inside of a structure. We can also have variables inside of a structure. But it doesn't matter what they are, whether it's constant or variable. These are considered properties. So var or constant inside of a structure equals properties. Okay? Just want to make that clear. So when I say properties, know that I'm talking about variables inside of a structure. And this will also actually apply to classes too. So, I just wanted to introduce that because I think I said earlier properties or something like that. But I just want to make that clear that we still use the format of, or how we create variables and constants. The thing is where it's located. So in this case, these two constants are inside of structure. So therefore, they're considered a property, an immutable property. So a property cannot be changed once it's set. Okay. All right. So let's have fun. Let's try out our first method. So let's create another player. So I'm going to do player 3, but he's going to be actually, I think I'm going to change that because I declared player as a person, so I'm actually going to do person extended just because it just makes more sense that way. Okay, so person extended. Alright, and we see we have first name, last name, just like above. So let's create a new person, say Vivian Cortez, why not? Okay, so we create a new person extended. thing is that this person, player 3, has a method that we can actually use. And this method allows us to pull out the full name without, doing extra stuff. So let's do player 3. If you notice, we have first name, we have last name, then we have our wonderful new method that we created, which is full name. So let's go ahead and hit enter. And you see it outputs her full name in one string. It's beautiful. Okay. All right. Now, the one thing I wanted to mention is that a struct is basically created to kind of enforce immutability. That's why I was using constants originally. The thing is when it's a better way to control what's going on. But sometimes you do need to have variables inside there, and everyone knows you can change your name. So the thing is if you wanted to, have this functionality where the person could not change the name once it's set because of whatever reason you defined in your code, then this is one way you can kind of control that, so you don't have weird things going on. I'm pretty sure down the road I'll show you an example of using a structure with constants and why I do it, but in this video I'm not going to do that. I just wanted to mention that usually that's what structures are kind of used for. But in this case, I'm going to allow someone to change their name. Say they made a mistake or they misspelled something, because, people, we all make mistakes, right? All right, so I'm actually going to change it to var, and you see it, nothing happens. One thing I actually wanted to show you, I'm going to actually change it back to let, is if I try to change player 3's first name to something, let's say it wasn't Vivian, but it was Viv. She wanted to be known by her nickname. So you see, we have this huge error that we can't assign a property first name because it's a constant. So Slip automatically asks, well, hey, you can fix it to make it mutable by changing a constant to a variable, which we can. So that's why I wanted to show you that. Now say, for example, this wasn't let, these were vars. If I try to change player 3's first name again, let's see what happens. Okay, we get another error. Why is that? Well, the thing is that because I made player 3 when I created this instance of player 3, I created it as a constant. So see, that's another way you can really shut down what a person or you can create boundaries by using constants. And this is another way. Even though I said, okay, yeah, I wanted the person to be able to change their first name or last name. The thing is when I first set this instance of player 3, I said this instance cannot have its value changed, even though it's using a structure that has mutable properties. Okay? So that's another way you can do it, instead of, creating, constant properties or immutable properties. You can also set what the mutability or lack thereof is when you first create the instance of one. So, there you go. Now, let's say I want to change to Viv, so let's go ahead and change that to var. And when we call player 3's full name again, we will see it's now Viv Cortez instead of Vivian. Okay? So yeah, fun stuff. All right. So I believe that's it for this video. Let's see, I briefly went over what I'm going to be covering in general for this video, as well as my other sets of videos in the future. Structures and classes. I've shown you the structure syntax. Gave you an example of something we've already did, which was we worked with tuples, and then shown you how a structure is set up based off of something that we've already worked with. Then I introduced the concept of instances, or initializing a structure, by creating a couple instances and showing you that yes, they share the same structure, but they have different values. Okay? And then how to access it by using dot notation. And then introducing functionality by creating methods. I also introduced the concept that yes, there's variables and constants inside structures, but they're called something a little bit different. They're called properties. And then also functions can be used inside of a structure too, but it's called something entirely different, which is methods. And then I kind of shown you how to utilize immutability and mutability using a structure, and how you can change it up a little bit. All right, I hope you enjoyed this video. If it was helpful for you, definitely give it a thumbs up. If you like any of my videos and you want to, stay tuned for other stuff that I load up, definitely subscribe. That's the best way to know when I load up something. Again, hope to hear, or hope you see my videos again, or whatever. All right, code on, my friends.